In Iceland, the ground started moving before anyone could see the disaster coming. Thousands of earthquakes ripped through the same region in just a matter of weeks, while satellites revealed something far more disturbing. The land itself was slowly rising, pushed upward by a force hidden beneath the surface. No one could say exactly where that pressure would break through, or what stood directly above its path. For nearby communities, uncertainty became the greatest threat. Families watched emergency alerts. Businesses prepared for sudden closures. Scientists monitored their instruments around the clock, knowing that the most important events were unfolding somewhere no human could see. This was not how volcanic eruptions were supposed to begin. Unlike the towering explosions many people imagine, the danger beneath Iceland was spreading silently through the Earth's crust. Magma was forcing ancient fractures apart underground, creating thousands of small earthquakes that were not separate events, but pieces of a much larger message scientists were still trying to decode. The immediate question seemed simple. Was an eruption approaching? But a deeper mystery soon emerged. Why had this region, quiet for centuries, suddenly awakened? Iceland has always been shaped by volcanic forces, but this activity appeared different. It was not centered around one familiar mountain or a single obvious source. Instead, the entire Reykjanes Peninsula seemed to be changing, as though a process that had been dormant for generations had quietly started again. Finding the answer required looking beyond modern instruments. Researchers compared satellite measurements with ancient lava fields, chemical signatures preserved inside volcanic rocks, and historical records written long before earthquakes could be measured. Slowly, evidence from completely different eras began pointing toward the same conclusion. The earthquakes were not an isolated crisis. They resembled the opening stage of a much larger geological cycle, one that had shaped Iceland before, then disappeared from human memory. The silence that followed was not proof that the volcanoes had vanished. It was only the pause between chapters. And if scientists were right, the eruptions making headlines today were not the end of the story. They were the first visible signs that an ancient chapter of Iceland's history had begun again. As scientists gathered more evidence, the recent earthquakes began to look less like a sudden emergency and more like the return of something remarkably familiar. The ground was not behaving randomly. It appeared to be following a pattern written into Iceland's geology long before modern cities, highways, and power systems existed. The clues came from places that seemed unrelated at first. Layers of volcanic ash buried beneath ancient landscapes, vast lava fields created by eruptions separated by centuries, chemical signatures preserved inside rocks formed during previous volcanic episodes. Even historical records written hundreds of years ago began matching what satellites and seismic instruments were detecting in the present. Together, these discoveries pointed toward an extraordinary possibility. The Reykjanes Peninsula was not experiencing isolated eruptions. It appeared to be entering a repeating volcanic phase. For centuries, the region had remained quiet enough that many people considered its volcanoes a distant memory, but the evidence suggested something far more unsettling. The silence that had lasted for generations was not proof that the volcanoes had disappeared. It was only the pause between chapters. The peninsula had entered similar periods of activity before, with eruptions occurring repeatedly over decades before eventually returning to another long, quiet period. That realization changed everything. The eruptions making headlines today might not be a single dramatic event with a clear beginning and end. They could represent the opening years of a volcanic chapter that future generations would simply consider part of life in Iceland. Meanwhile, the people living above this restless landscape had to adapt to a new reality. Emergency routes were reviewed. Infrastructure plans were reconsidered. Communities that had grown accustomed to stability suddenly had to prepare for a future where the ground beneath them could change again. Deep below the surface, the process continued. The North American and Eurasian tectonic plates were still slowly moving apart, stretching the Earth's crust and creating pathways that magma could eventually exploit. Long before lava appeared above ground, molten rock could travel through hidden fractures, breaking surrounding rock and producing thousands of earthquakes along the way. By the time an eruption became visible, the most important events had already happened underground. And that created the next great challenge. If scientists could detect the movement of magma beneath Iceland, why was knowing where it would finally emerge still one of the hardest predictions on Earth? Recognizing the pattern was a scientific breakthrough. Predicting what happened next was a completely different challenge. For the first time in modern Icelandic history, earthquakes were no longer simply signs of an eruption that had already begun. They became real-time messages from a hidden system still evolving beneath the surface. Every tremor, every millimeter of ground movement, and every new fracture revealed that magma was not following a simple path upward. It was searching. Deep underground, molten rock moved through weaknesses in the Earth's crust, creating networks of fractures that could extend for kilometers. Scientists could detect these movements, but understanding exactly where they would lead was far more difficult. Because magma does not recognize human boundaries. It does not know where roads end, where neighborhoods begin, or which areas contain vital infrastructure. It follows physics. To understand that invisible movement, researchers transformed the landscape into a giant monitoring system. GPS receivers measured tiny changes in the ground. Radar satellites repeatedly scanned the peninsula from space, revealing areas that expanded as magma accumulated below. Thousands of earthquakes were analyzed together, allowing scientists to build increasingly detailed models of where underground fractures were forming. But then came the most important realization. The challenge was not simply collecting more information. The challenge was that the Earth itself could change the answer. A magma pathway could suddenly stop. A new fracture could open somewhere unexpected. Pressure could redirect underground movement within days or even hours. A location that appeared most likely one week could become irrelevant the next. For scientists, this was a problem of prediction. For the people living above the magma, it was something much more personal. The warning signs were not just numbers on a screen. They represented impossible decisions, the difference between leaving home too early and disrupting an entire community, or waiting too long and facing consequences no one could reverse. When should thousands of people evacuate? How much uncertainty could a society accept? Should critical infrastructure be shut down before there was absolute proof of danger? There were no perfect answers. Waiting for complete certainty could mean waiting until there was no time left. As volcanic activity continued shifting across the peninsula, scientists and emergency planners reached an unavoidable conclusion. Monitoring alone would never be enough. If humans could not stop the volcano, perhaps they could at least influence what happened when it arrived. And that led to one of the most unusual experiments in modern volcanic history. Could engineering actually change the path of a force powerful enough to reshape the land itself? The first attempt to influence lava did not begin with a belief that humans could control a volcano. It began with a much smaller question. Could they change where the destruction went? No one believed an eruption could be defeated. The goal was not to overpower nature, but to gain something far more valuable: time. A few extra hours for evacuation. A few more days to protect critical infrastructure. A small advantage against a force that had been shaping the planet for millions of years. Before heavy machinery arrived, Engineers studied the landscape as carefully as possible. Satellite images, elevation maps, and real-time observations were combined to answer one question. If lava reached this area, where would gravity naturally take it? That answer would determine where defenses were built. Across the peninsula, engineers constructed barriers using volcanic material already covering the landscape. These structures were never designed to stop lava forever. They were built to influence its movement, to encourage flowing rock toward empty areas while protecting roads, energy systems, and important facilities. Then the predictions met reality. As glowing rivers of lava moved across the dark terrain, drones tracked their progress from above while emergency teams watched from protected locations. Some barriers performed exactly as expected. Others failed almost immediately, forcing engineers to adapt while the eruption was still unfolding. The volcano became a live experiment. From above, cameras captured something almost impossible to believe. Humans were not stopping a volcano. They were negotiating with one. And that experiment revealed something important. Lava was not a single predictable force. Its behavior depended on temperature, thickness, speed, and the shape of the landscape beneath it. A barrier placed in the wrong location could simply force lava around its edges. A carefully designed one could slow the advance and redirect the flow. The greatest breakthrough was not building a stronger wall. It was understanding that survival did not require defeating nature. It required understanding nature well enough to make small changes with enormous consequences. But every success came with a warning. These defenses could protect important areas. They could reduce damage. They could create precious time. They could never remove the risk completely. A new fissure opening beneath a community would leave almost no opportunity for intervention. No barrier could be constructed quickly enough. No model could guarantee where the earth would choose to break next. And that changed the meaning of the entire effort. This was never truly a battle against lava. It was a race between an unpredictable planet and a civilization trying to prepare before the next transformation began. Because beneath Iceland's surface, the forces that created the danger were still active. The next challenge would not be stopping the volcano. It would be learning how to live with one that refuses to stop. The recent eruptions may have changed how Iceland sees its future. Not because every year will bring catastrophe, but because scientists now understand that the quiet period may have been the unusual part of the story. The Reykjanes Peninsula may have entered a new volcanic chapter, one that could continue long after the people witnessing its beginning are gone. The challenge is no longer preparing for a single eruption. It is learning how to live with a landscape that has started moving again. For communities across the peninsula, adaptation has already become part of everyday life. Evacuation plans are constantly updated. Critical infrastructure is redesigned with future eruptions in mind. Scientists continue analyzing earthquake patterns and satellite measurements, searching for the smallest signals that reveal what is happening beneath the surface. Every eruption becomes another lesson. Every failed prediction becomes new knowledge. Every successful decision improves the response to the next event. But one reality remains impossible to change. The Earth will always have the final decision. Lava can sometimes be redirected. Roads can sometimes be protected. Power systems can sometimes be reinforced. But if the ground opens beneath the wrong place at the wrong moment, humans cannot stop the process. They can only respond. And perhaps that is the most important lesson Iceland has discovered. Survival does not come from controlling nature. It comes from understanding it early enough to make better choices. Because volcanic landscapes reveal something humans often forget. Creation and destruction are happening at the same time. The same lava that threatens communities today will eventually cool into solid ground. The same eruption that forces people to leave their homes will one day become part of the landscape, preserved in rock for future generations to walk across. The disaster of today slowly becomes the foundation of tomorrow. Years from now, visitors may travel across fields of hardened black lava without realizing they are standing on land that did not exist before their lifetime. They may see a quiet landscape and never imagine that it was once a place of earthquakes, evacuations, and glowing rivers of molten rock. But beneath their feet will remain evidence of a moment when humanity faced a force it could not stop. Only understand, because Iceland's greatest achievement was never defeating the volcano. It was learning how to listen to a planet that was always changing. The earthquakes, the eruptions, and the rising ground were never signs that the Earth had lost control. They were reminders that the Earth was still alive. And perhaps that is the deeper story of Iceland. Not a story about humans conquering nature, but a story about a civilization learning its place within a world that has always been moving.